Joy Zeigler here. Let's go ahead and get started with part 4 for the review for the final. In this problem, you're to rationalize the denominator, which means to eliminate any radical from the denominator. And when you have a sum like this, then if you multiply it by its difference or its conjugate, then you will effectively get rid of that radical. So let's go ahead and do this. I'm going to put this in parentheses to remember that it's a unit. And we're going to multiply the denominator by its conjugate, 5 minus square root of 3. But we have to do the same thing in the numerator. And that gives us, on top it gives us 7 times 5 minus square root of 3. And what does it give us on the bottom? Well, let's go down here. We remember our formula, a plus b times a minus b equals a squared minus b squared. Do we have that? Yes, we do. We have a is 5 and b is square root of 3. So a plus b times a minus b gives us a squared minus b squared. So that would be 5 squared minus square root of 3 squared. So we're going to keep our numerator as it is right now, 7 times 5 minus square root of 3, and simplify our denominator, 25 minus 3, because the square root of 3 squared, square root and square are opposites, so you end up with the radical, the radicand. So that's going to give us 22 in our denominator. So let's go ahead and multiply out our numerator, 35 minus 7 square root of 3 over 22, and that's our answer. We are to complete the factoring of this, so we want to do a few things. We want to find common factors, and then we want to factor out that negative sign. So we are going to divide by whatever the common factor is. And we can see 11 goes into here, here, and here. And then we look z, z, z. We take the smallest exponent, and that gets factored out. So we are factoring out negative 11z to the 4th. And that'll take care of the negative sign and all the common factors. So we divide each term by negative 11z to the 4th to find out what goes in the parentheses. And we can see it's z squared, and then negative 55 divided by negative 11 is positive 5, and then z minus, because in the last term we have a positive divided by a negative, so that's going to be a negative 22, and the z to the 4ths cancel. So now we have to see if we can factor this. We need two numbers that multiply to give us negative 22 and add to give us 5. And so what we want is we want two numbers that multiply to give us negative 22 and add to give us 5. And we're going to have 11 and negative 2 as the only possibilities, and that'll give us 9, so that doesn't work. So that tells us that this cannot be factored further unless you end up with complex numbers. So this is our final answer. Here we're to graph a line, so our first job is to put it into slope-intercept form. So we want to get our y term by itself, and that means subtracting 9x from both sides. So we have 3y equals negative 9x minus 15. And then we divide by 3, and we get y equals negative 3x minus 5. And now we have everything we need to graph our line. We know where it crosses the y-axis. It crosses at negative 5. and we know that the slope is -3. So it's going to run downhill. So we count up 1, 2, 3, and over to the left 1 for another point, and then we can count up 1, 2, 3, and over 1 for a third point, and then we can draw this. I didn't do a very good job, but you get the idea. And that is how you graph a line. Okay, in this problem we have to simplify, and so we have to see if we can create like terms. Right now the square root of 75, the square root of 48, and the square root of 147 can't be combined. They're all square roots, but they don't have the same radicands. So we want to see if we can get the same radicands. When you look at each one, you want to figure out if you have a factor that is a perfect square under the radical sign. 75 is 25 times 3, and 25 is a perfect square, so let's go ahead and write that. So we have 7 over 25 times 3. 48 is 16 times 3, and 16 is a perfect square. And then we have 147, and it turns out that 147 is 49 times 3, and 49 is the perfect square. So, since 25 is 5 squared, 16 is 4 squared, and 49 is 7 squared, we can pull out the 5, 4, and 7. So we get 7 times 5 square root of 3 minus 4 square root of 3 plus 4 times 7 square root of 3, and that gives us 35 square root of 3 minus 4 square root of 3 plus 28 square root of 3, and that's the same as just adding the numbers all together, and then that will be times the square root of 3, and so that gives us 59 square root of 3 for our answer. Okay, when you solve a problem like this where you have variables in the denominator, you have to make sure that your solution set isn't going to include anything that will make any of these, well, that will make a denominator equal to 0, because division by 0 is undefined. So in the first case, a minus 3 can't be 0, so a can't be -3. In the second case, a plus 3 can't be 0, so a can't be +3. Now the third case, a squared minus 9 is the difference of squares, a squared minus 3 squared, which is going to be a plus 3 times a minus 3. And neither of those can be 0, but we've already taken care of those cases, so 3 and -3 are not allowed in our solution set. Now let's go ahead and solve. We need a common denominator, and that common denominator is going to be a squared minus 9, because a squared minus 9 contains a plus 3 and a minus 3. So what do you have to multiply the first denominator by to get that denominator? And the answer is you have to multiply by a plus 3. So we rewrite this as a over a minus 3, and then we're going to multiply it by a plus 3 and a plus 3. And then the second, we have 1 over a plus 3, and we have to multiply that by a minus 3 over a minus 3. And we don't have to multiply the denominator on the other side. We can go ahead and factor it so it looks the same. But it already has what we want. So we rewrite this as a times a plus 3 over a plus 3, a minus 3, plus 1 times a minus 3 over a plus 3, a minus 3, equals negative 6 over a plus 3 and a minus 3. Now, since the denominators are all the same, we don't need to worry about them anymore, except to remember that we can't have 3 or negative 3 in the denominator. So essentially, if we multiplied both sides of the equation by a plus 3, a minus 3, the denominators would cancel out, and we have left a squared plus 3a plus a minus 3 equals minus 6. And that gives us a squared plus 4a minus 3 equals minus 6. Adding 6 to both sides, a squared plus 4a minus 3 plus 6 is plus 3, and that gives us 0. And now we see if we can factor this, which we can. We get a plus 3 times a plus 1 equals 0. Now our zero factor property says that if you have two numbers that multiply together and equal 0, that means each one might equal 0, but one or the other one has to. So either a plus 3 equals 0, meaning a equals negative 3, or a plus 1 equals 0, and that means a equals negative 1. But we look back at what we said earlier, that we cannot have negative 3 or 3 for our a's, so we need to disqualify the a equals negative 3 as a possible solution. So the solution we end up with is negative 1. This problem tests your knowledge of the principle that a minus b equals negative b minus a. So here we can have a minus b, or t minus s. That's going to be the same as negative s minus t. And the reason that's important is because now we have s minus t as both denominators, only we have a negative sign in front of the second one. So rewriting this, we get s over s minus t minus t over negative s minus t. Well, that negative sign, anything divided by a negative is a negative, so this whole fraction is a negative. So that means we can move it over here, and that gives us minus a negative, which is plus a positive, and so now we have s over s minus t plus t over s minus t. Now we have the same denominator, so we can add the numerators and keep the denominator the same, and that's our solution. Okay, determine if the graph is a function and give the domain. And what we're going to do is we're going to use the vertical line test. If you can draw a vertical line anywhere on this graph that makes it cross the graph in two places, then it is not a function. In this graph, that isn't happening, so the parabola that is going downwards is a function. So the answer is yes, it is a function. So yes, a function. Okay, and domain is the x values. This graph, how far to the left and how far to the right does it go? Well, if you think about this going infinitely on forever, you see that x goes infinitely to the left and infinitely to the right. So the domain is all real numbers. Domain equals all real numbers. Okay, when you add two fractions, you must have a common denominator. So that's what we're going to work on here. First, we're going to factor each fraction separately. Then we're going to find the least common denominator, and then after we do that, we can add the numerators. So, the factorization of x squared plus 10x plus 25, well, that's a perfect square trinomial, so that's just going to be x plus 5 squared. The factorization of x squared plus 2x minus 15, we want two numbers that multiply to give us negative 15 and add to give us negative 2, and that would be 5 and negative 3. So the factorization is x plus 5 and x minus 3. So let's write it here. The first is x plus 5 squared, and the second is x plus 5 times x minus 3. The greatest common denominator is going to have the highest exponent of the common factors, so x plus 5 shows up in both of them. We take the one with the highest denominator, and then we have to have at least one occurrence of every factor. So our least common denominator is going to be x plus 5 squared times x minus 3. So let's rewrite our original equation. We have 7, and we are going to use our factorized denominator x plus 5, x plus 5, x, and that's all right now, plus 4 over x plus 5 times x minus 3. So in our first case, we want our least common denominator to be x plus 5 times x plus 5 times x minus 3. So we need x minus 3. So we multiply the first one by x minus 3 over x minus 3. And in the second case, we multiply by x plus 5 over x plus 5. And so that gives us 7x minus 3 plus 4x plus 5, all of that over x plus 5, x plus 5, x minus 3. So that gives us 7x minus 21 plus 4x plus 20 over that same denominator equals 7x plus 4x is 11x, minus 21 plus 20 is 1, so 11x plus 1 over x plus 5 squared times x minus 3. And that's the answer. Subtract and simplify. So first we're going to distribute that negative sign. And then we're going to say minus a negative is plus a positive. So we have 3 plus 5i plus 3 plus 2i. And that gives us 6 plus 7i. And that's our solution. Now continue on to part 5 of the final exam review for Math 310.